Now let's see how to graph function using compressions and stretches. So we talked about earlier, when the function change is associated with multiply or divide, that's the transformation techniques is the stretch or compressed. All right, and it also have two directions. Either x change or y change. Okay, and then if x change, and then the stretch compress should be in the horizontal direction. Okay, this is a stretch. It's like a two, you just consider there's a string in your hands, and then you just pull of your two hands, away from each other. Okay, in the opposite direction. That is the stretch. Okay, compress, that's like you squeeze a string, okay, to the smaller. So that's the compress. Okay, the power, okay, goes towards each other. Okay, this is the like a force is pull away from each other. Okay, that is the stretch. This is the compress. And the vertical direction is the same way. Okay, stretch is pull away from the opposite direction, and then the compress is this way. All right, and then x change again is the inside function. Use x, replace x by c times x or x divided by. All right, let me write it up. Okay, so replace x by either c times x or x divided by c, or 1 over c times x. All right, if the y change is c times f of x or f of x divided by c. Okay, that's the y change. Very similar as we talk about the shift. Okay, x change, y change applies here similarly, but the only thing different this time is not the adding, subtracting. Now we're working on the multiply or divide. All right, let's look at the example. So f of x equals square root of x. We still use square root function, okay, as illustrating. And then g of x equals 2 times square root of x. So 2 times square root of x we can write as 2 times f of x, right? So 2 times f of x multiply, right? 2 times y. So that's multiply. That's why we use either stretch or compress. So which one is that? And then this is a y change, right? And then we know this is a y change. So that means it's a vertical direction. Okay, so it's a stretch or compress. We look at this number. If this number is a number greater than 1, and then it's a vertically stretched. Okay, so this transformation is vertically stretched. Vertically stretched by what? By 2. Okay, or in other words, since it's a y change, so x remain the same. Okay, x remain the same, and then the corresponding y all stretched by 2, or y times 2. Okay, correspondingly. All right, that's vertically stretched by 2. So let's look at in the point of view, okay? Look at the points. Original function, square root function is 0, 0. Okay, and then after vertically stretched by 2. X remain the same. Y times 2, 0 times 2, still 0. Okay, and then when x equals 1, square root of 1 is 1, right? That's original square root function. Now y vertically stretched by 2, so y multiplied by 2, that's 2. All right, if x equals 4, and then square root of x equals 2, and then y vertically stretched by 2, right? So g of x is 4. X remain the same, okay? And then if x equals 9, square root of x is 3, but vertically stretched by 2, and then same x, y multiply by 2. Okay, so everything is y coordinates multiplied by 2 when x remain the same. That's the effect when you do vertically stretched by 2. So from graph point of view, okay, the black color, that's initial square root function. Now you vertically stretch by 2, so same thing. When x remain the same, y times 2, right? Here it's supposed to be 1, 1. Okay, when x is the same, y multiplied by 2. Okay, so this point become here. When x is the same, and then y times 2. Okay, and then this can go on forever. So from the graph, it's like you vertically drag this graph, you know, more up. How much up? Doubles the y coordinates. All right, so that's the transformation vertically stretched by 2. So what about compress? Okay, so let's see. F of x equals absolute value of x. So this time the key function we use absolute value function. And then g of x equals 1/2 of absolute value of x. Okay, so multiply by 1/2, right? Multiply. Operation is a multiply. So it must be stretched or compressed. And then this is x change or y change. So this is f of x, right? We can rewrite as 1/2 times f of x. So this is x change or y change. This is 1/2 of y, right? Outside the function multiplied by 1/2, right? So this is a y change. All right, and then the coefficient 1/2 or divided by, right? Y divided by 2. That's why is vertically, okay, y change, that's indicate the direction is a vertical direction. Vertically compressed by 2 because it's divided by 2. Right? Multiply is vertically stretched, and then divided by 2 is vertically compressed by 2. Or it's the same like a multiply by 1/2. Okay, divided by a number is the same as multiply by its reciprocal, right? So let's look at a graph. Okay, let's look at the data table. Okay, when x is remain the same, okay, y is divided by 2, right? When x remain the same, original absolute value function, and then y divided by 2, divided by 2, divided by 2, right? 0 divided by 2 is still 0. 1 divided by 2, 1/2. 2 divided by 2, 1, right? So x remain the same. Y divided by 2, that's vertically compressed. So what about a graph? This black color V, that is the original absolute value function. And then vertically compressed by 2, you just imagine you use hand press this V down, right? Compressed. So for the same x, y compressed by 2. So every y coordinate's got a half of this original absolute value function. Okay, x coordinates remain the same, and every point y coordinates will compress by half. That's in the vertical direction. All right, horizontal direction, it will be a little bit, opposite. All right, let's see. this is a summarize the vertical direction. If original function y equals f of x, and then y equals a times f of x, okay, a times f of x outside of the function multiplied by a, right? That's the y change. That's why it's a vertical direction. So if a is a value greater than 1, and then it's vertically stretched. If a is a number between 0 and 1, less than 1, right? And then that's a vertically compressed. It's like a divided by number, right? That's what we talked about earlier. So that's in the vertical direction, y change.